Can you see the screen?
Yes, sir.
Okay. So next topic is in fifth unit, development of surfaces. So what is the development of surface? Suppose if you open a solid object, assume that the object is made by a thin sheet or a paper. And if you open the complete solid, and place it on a plane or surface, the object, the shape, what you are getting is the development of surface of that particular object. So what is the use of this one is, suppose if you want to prepare any closed, suppose if we take automobiles or any even toothpaste box, any boxes. So if you want to produce or manufacture that box, we have to first get the template. Is it or not? A template prepare చేసుకుని if you close that, you'll get the required object. So object prepare చేయాలంటే first we have to design the its developed surface. So development of any solid shows its true shape of all the surfaces of the solids. So when solid object kuna any surfaces ni, if we keep side by side, we'll get the developed surface. And the development of lateral surfaces means, so most of the cases in our problems we're going to use only the development of lateral surfaces, means neglect the base and top. By neglecting the base and top, we're going to draw the development of only the lateral surfaces. And our syllabus is limited only up to simple solids with simple cutting plane. Now, in development of surfaces, there are two methods. The first method is parallel line method. Parallel line method is useful for development of prisms. Why? Because if you open the surface of a excuse me. If you open the surface of any prism, see here a square prism. When you open the square prism, these are the four rectangular faces and top base and bottom base. So these are kept open. Now, if you observe, all these lines are parallel to each other. The edges of these rectangular faces are parallel to each other. So it is developed by first constructing a rectangle of length equal to the total perimeter of this prism or perimeter of this base and height equal to the axis height, and then drawing the parallel lines representing the straight edges. So that's why it is called as parallel line method and useful for the development of a prism. See here an example for a development of a square prism. So first draw the square prism in its initial position, the basic position, that is that the base is on HP, top view and front view. Now if you open it, so what is the total perimeter? As it is a square, 4 times the square. So draw a horizontal line equal to 4s and height equal to axis height, complete the rectangle and then measure the distance from A to B. A as center, mark a point B. B as center, mark a point C. C as center, mark point D. D as center, mark point. Again, you'll get A. So this is the method of drawing development of a surface for a prism by using parallel line method. And now, in front view, we are representing the points as A dash, B dash, C dash. In top view, A, B, C, D, small letters. But in developer surface, we'll represent them with the capital letters. Suppose if you open it, starting from point A, the first side AB, second side BC, third side CD, and again fourth DA. So you'll get the repetition of the point A and similarly the point P, top base point and bottom base point. So for the development of a pyramid, the method is called as radial line method. Means if you open a pyramid, surface of the pyramid will get the triangles depending on the number of sides of the base. Suppose if it is a square pyramid, we'll get the 4 triangles. Suppose it is a pentagonal pyramid, we're going to get 5 triangles. And all these triangles, these slant edges are joined towards this apex point O. So all these lines looks as a radial lines for a circle. So that's why it is called as a radial line method. So this is example how to draw the development of a pyramid. So first the pyramid is drawn as per the given dimensions. And now the main thing is you have to identify the true slant length. Suppose if you observe AO, BO, CO, DO, all these lines are inclined to XY line in top view, inclined to XY line in front view, means these lines are inclined to both the planes. So what we have to do is rotate OA or any slant edge up to the horizontal position, a parallel line to XY line, project this up to XY line, you'll get the point A1 dash. So join A1 dash to O dash. This will be the true slant length. Now, taking the true slant length as radius at any some random point, taking point O, and with the radius equal to true slant length radius, draw an arc. Draw an arc and mark the initial first point as A. Now, measure the distance from A to B, the side length. A as center, if you draw an arc, you'll get point B. B as center, draw an arc, we'll get point C. C as center, point D. D as center, A. Join all these points towards apex point. So this is the way of drawing development of surface for a pyramid. Now let us move on to a problem. Write down this problem. Draw the development of lateral surfaces of a right square prism of edge of base 30 mm and axis length 50 mm. So I'm giving you 2 minutes time. Try to draw the prism in the initial position. Start it. Draw the prism in the initial basic position. The position is not given in the problem. So we have to assume the prism is resting on its base on HP and the axis perpendicular to HP. So in top view, true shape, in front view, the rectangular faces. Draw this. ఇది స్టెప్ బై స్టెప్ ప్రాసెస్ లేదు సో నేను కంపల్సరీ మనం స్టెప్ బై స్టెప్ ప్రాసెస్ లేదు పీపీటీలో అందువల్ల మనకి ఎక్స్ప్లెయిన్ చేయమని Is it completed? Draw చేశారా? Yes or no? ఎవరైనా ఒక్కడైనా కంప్లీట్ చేశారు అట్లీస్ట్ Is it audible? No one is responding. Is it audible or not?
Yes, sir.
Yes, sir.
మరి డ్రా చేశారా డ్రా చేయమని చెప్పాను ఎస్ అని చెప్పట్లే ఎవరు Development of lateral surfaces of a right square prism. Edge of base 30 mm and axis 50 mm long. I'm typing the problem in chat box. Draw the development of lateral surfaces of a right square prism, edge of base 30 mm. So initially draw the square in its basic position, top view, as it is a prism A, B, C, D. 4 corners on one base and 4 more corners on the other base. E, F, G, and H. Now project all these points onto top view. Mark the axis point, also project this axis point. First draw the axis of the prism and then complete the projection of the square prism. Now we have represented A, B, C, D as visible points in top view. So A, B, C, D are on the top base. A dash, B dash, C dash, D dash. D and A are hiding. Similarly, E, F, G, H hiding points in top view are on the base. E dash, F dash, G dash, and H dash. Now, drawing the development of this prism. Drawing the development of this prism. Draw a horizontal line, almost matching the XY line. So, along with this XY line, draw horizontal line, length equal to perimeter of this square, 4S, 4 into 30, here it is 120 mm. And complete the rectangle with height equal to axis height. Complete this rectangle. Now, assuming that we are opening this solid based on the corner A. So what are these points? A, E. So mark this as A, E, capital X. Now, take the distance equal to side of this square, 30 mm, A as center, mark point. B, B as center, mark point. C, C as center, if you mark point, getting D. Draw the parallel lines. So the edges AB, BC, CD, and again DA. So the other end EFGH. F, G, H, and again E. So this is the development of the lateral surfaces of a square prism. Coming to dimensions, we have to represent the dimension of its total length. It is 120 mm, and the side length (30 mm), axis height (50 mm). So this is the way to draw the development of a prism. Do you have any doubts in this? Any of you having doubts in this?
No, sir.
Drawing the lateral surfaces of a development of a prism. Now, move on to the next problem.
సార్ మరి అప్పర్ అండ్ బాటమ్ సర్ఫేస్ అది ఎలా చెప్తాం సార్?
ఏంటిది?
స్క్వేర్ ప్రిజం కి మామూలుగా సైడ్స్ కాకుండా టాప్ బాటమ్ కూడా ఉంటాయి కదా సార్?
Yes, top is జనరల్ గా ప్రాబ్లమ్ లో దగ్గర డెవలప్ ద లాటరల్ సర్ఫేసెస్ అని క్లియర్ గా మెన్షన్ చేస్తారు. నో నీడ్ టు డ్రా ద టాప్ బేస్ అండ్ బాటమ్ బేస్. అలా కాకుండా ఇచ్చారు అనుకోండి, యూ హావ్ టు డ్రా ద టాప్ బేస్ అండ్ బాటమ్ బేస్ అట్ ఎనీ వన్ ఎడ్జ్. ఏదో ఒక ఎడ్జ్ దగ్గర టాప్ బేస్ అండ్ బాటమ్ బేస్ on one more side. ఇట్లా two sides దగ్గర two squares represent చేస్తాం. As it is AB, CD. Similarly, EFGH. Full completed. Suppose if they ask you to also draw the base. Base కూడా complete చేయమంటే base ని two bases ఉంటాయి for a prism. So both the bases will represent it as a squares at any one edge. Okay, is it clear now?
Yes, sir.
Now, coming to the next problem, development of a cylinder. You may get these two problems only for 2 marks. Why? Because simple problems without any cutting plane. So, in examination point of view, a simple problem, development of a prism or pyramid without cutting plane, you may get this for short answers. So, see the second problem, I typed it in the chat box. Development of a cylinder. Same as the prism. So first draw the development of a complete surface of a cylindrical drum. Diameter is 40 mm and height 60 mm long. So first draw the circle in the initial position. Divide this circle into 8 or 12 divisions. Divide this circle into 8 or 12 divisions. Project each and every point. Let this be A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R and S. 8 points on top base and 8 points on the bottom base. So the projection of a cylinder in front view, it looks as a rectangle, only highlighting the outermost generators. What are these points? A dash, draw the internal generators with 2H pencil. B dash, C dash, D, E, F, G, H. Is H. Next, J dash, K, L, M, N, O, P, Q, and R dash. So first draw the front view and top view of the cylinder in simple position. Now the developer surface. She is asked to draw the complete surface. So first the lateral surface. If you open a cylinder, what is the total length we're getting? What is the total length of the surface? Any of you? If you open the cylinder, What is the total length of the surface?
Circumference of surface.
Circumference, yes. So the circumference equal to pi d. Calculate this value, pi into 40 mm. The diameter of the circle, pi into 40. Any of you calculate it?
125, sir. 125.6.
No. So draw a straight line, length equal to 125.6. Length equal to pi d. 125.6. Now complete the rectangle with the height equal to axis height 60 mm. Now, order this, assume that you are opening based on the edge of the generator AJ. Name this as AJ. AJ. What about the remaining points? We have divided the circle into 8 divisions. Is it visible now?
Yes, sir.
Is it clear video?
Yes, sir.
Why? Because I'm connecting through mobile net, power problem in the college. So if there is any disturbance or unable to see the screen clearly, inform me. Now, as we divided the circle into 8 divisions, divide the line between the total circumference also into 8 parts. What is the process? Inclined line method. By draw an inclined line at some randomly at 40 to 45 degrees, and then take compass, set radius equal to 1 or 2 centimeters, any convenient radius, mark points 1, 2, 3, 4, 5, 6, 7, 8 points. Join the 8th point to J. Join this last point to J. Now draw the parallel lines from all these remaining points. Draw the parallel lines from all these points. Mark these points as starting from J, K, L, M, N, P, Q, and R. Draw vertical lines from each and every point. B, C, D, E, F, G, H. So this is the way of drawing the development of. Suppose if you ask for the complete surface, we must also show the circle. So at any one point, draw the complete circle. Showing the, so draw a circle with radius equal to the radius of the base circle, 40 mm. So this is a way of drawing development of a cylinder. Now move on to the third problem.
సార్ వీడియో బ్లర్ అవుతుంది సార్.
Yeah. Just wait for a minute. ఒక 2 minutes wait చేయను, కనెక్ట్ చేస్తాను. No internet at all. Is it clear?
ఇప్పుడు వస్తుంది సార్.
It was no. So go for the next problem. With cutting plane or with sectioning. See the chart box. The hexagonal prism edge of base 20 mm and axis 50 mm long rests with its base on HP such that one of its rectangular faces is parallel to VP. It is cut by a plane perpendicular to VP, inclined at 45 degrees to HP, passing through the right corner of the top face of the prism. Read the problem clearly and identify the major points. The first one is shape and size of the components and its orientation. Shape and size of the object. It is hexagonal prism resting with its base on HP. So in top view, we must draw its true shape. So while drawing the true shape, one more condition is given, that is rest with its base on HP such that one of its rectangular faces is parallel to VP. Draw the hexagon, the initial view, with one of its sides parallel to XY line in top view. So name, as it is a prism, name the corners as A, B, C, D, E, F, G, H, I, J, K, and L. Draw its respective front view. Project each and every corner. First the axis point, and also all the corners. as it is resting with its base on HP. The initial view, one of the base must be projected only up to XY line. So on XY line, mark the bottom base points. Those are G, H, I, J, K dash and L dash. Now draw the axis for the given height. Extend or remaining straight edges to the given height. Name these points as A dash, B dash, C dash, D dash, E and F dash. Now observe the cutting plane. It is cut by a section plane inclined at 45 degrees to the HP and perpendicular to VP. As the cutting edge is perpendicular to VP, it is seen as a line in front view. If in a front view, the cutting plane is represented as a line inclined at 45 degrees to HP. And its position, one more condition is given. It is passing through the right corner of the top face of the prism. So this is the top face of the prism. So on the top face, right corner means passing through D dash. The cutting plane is passing through D dash. So draw a 45 degrees inclined line passing through D dash. So this is the cutting plane. Now mark the point where this cutting plane is intersecting the straight edges. It is passing through point D. So on AG, it is cutting at 1 dash, 2 dash, 3 dash, 4 dash is intersecting with D dash. And again, on EK edge, 5 dash, on FL edge, 6 dash. So it is intersecting at 6 points. Project all these points onto top view. 1 dash is on AH edge. So at this point this is 1. 2 is on BH. Point 2. 3 is on CL. 4 is at D. 5 is at EKH. So this is 0.5, 0.6. Complete it with the hatching. So in top view, fill the complete solid, complete hexagon with hatching. Parallel lines at 45 degrees inclination. So this is the first step, drawing the projection of the prism. Next, sectioning of the prism. Now go for the third step, development of the prism. The next step is development of the prism. So for development of prism, draw a horizontal line coinciding with this bottom base. Coinciding with this bottom base, length equal to total perimeter of the hexagon. What is the side of the hexagon? Side length is 20 mm given in the problem. So draw a straight line equal to 20 into 6, 120 mm. Draw a straight line equal to 120 mm. And height equal to axis height. The axis height is 50 mm. Axis side is 50 mm. Now, assuming we are opening the hexagon based on the corner AG. So name these points as AG. Now mark point at every 20 mm. At every 20 mm. B, C, D, E, F. Draw vertical lines. B, C, D, E, F. Next on base, G, H, I, J, K, and L. So actually this is the development of only the lateral surface without sectioning. What we have drawn now is only the development of lateral surface without sectioning. But it is cut by a section plane. It is cut by a section plane. So the section plane is passing through the edge AG at 1 dash. AG at 1 dash. So project this 1 dash. So on the edge AG, name it as 1, 1. This is also line AG. So you are getting 2 lines for AG. So point 1, 1. So point 2 and 6. Point 2 is on BH, 6 is on FL. So draw a parallel line from this. 2 is on BH. So this is point 2. 6 is on FL. Point 6. Next, 3 and 5. It is on CL and EK edges. 3, 5. Sorry. On CI 3, EK 5. Point 4 is coinciding with the corner D. So this is point 4. Join all these with a straight line. Join 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 1. Highlight only the retained part, means only the bottom part, leave the upper part with 2H. I am showing it in the presentation. First step is drawing the hexagon in top view and projecting to the front view, completing the projection of the hexagonal prism. So after completing the hexagonal prism, draw a section plane passing through the right top corner. Right top corner is D dash. So passing through D dash, draw the cutting plane. Now, drawing the development surface. First draw the development surface, length equal to the total perimeter 6 into 20, 120 mm, and height 50 mm height. Complete the rectangle and draw the parallel lines at every 20 mm, indicating the parallel straight edges. Now draw the projections from 1 dash. 1 dash is on the edge A. 2 and 6. 3 and 5, and 4 is coinciding with the D. Join 1, 2, 3, 4, 5, 6 with the straight edges. As we are cutting the solid and removing the upper part, so leave the upper part with 2H, highlight only the below bottom part, the part between cutting plane to the XY line. So this is the way of drawing projection of a prism when it is cut by a section plane. Do you have any doubts? Any of you having doubts?
No, sir.
So now move on to the next problem. Hexagonal prism of base side 20 mm and height 40 mm is resting on one of its ends on HP with two of its lateral faces parallel to VP. So here the variation, previous problem, one of the rectangular faces parallel to VP. Here, two of the lateral faces parallel to VP. It is cut by a plane perpendicular to VP and inclined at 30 degrees to the HP. The plane meets the axis at a distance of 20 mm above the base. Draw the development of lateral surfaces of lower portion of the prism. So most of the cases, the default one is we're going to draw only the projection or development of only the lower portion. Lower portion is the portion between cutting plane to the XY line. First step, draw the projection of the prism. Draw the projection of the prism. So the initial view with two of its lateral surface parallel to XY line in top view. Complete the top view and project it onto the front view. And here it is given as the cutting plane is passing. The cutting plane is passing, meets the axis at a distance 20 mm above the base. It is meeting the axis at a distance 20 mm above the base. So mark a point 20 mm above the base. From this point, draw a 30 degrees inclined line. This inclined line may be towards right forward or left hand side. We can show this representation to any direction, either to left to right or right to left. And now mark the intersection point of this cutting plane with the straight edges. It is cutting the straight edges P dash at 1 dash, Q dash at 2, R at 3, S at 4, T at 5, and U at 6. As it is clearly given, draw the development of the bottom surface, means the upper part is to be removed. Now draw the development of the hexagon. First draw the development of the hexagon is rectangle. Length equal to total 120 mm. Mark point at every 20 mm. And then project each and every point. 1 dash is on the edge from P. So project 1 dash up to P. 2 dash on 2 and 6 or on Q and U. 2, 6. 3 is on R, 5 is on T. 4 is on S. So mark these points and join them with a straight line. So this is the way to develop the lateral surfaces of a prism when it is cut by a section plane. The main thing is you have to draw this figure. So drawing this figure only taking time. Developing is easier. A simple process. Next, I'm giving this problem 6 as an exercise. I'm not explaining it in class. Complete this. Now, let us go for a cylinder. The only variation between the cylinder and the prism is, in cylinder, the lateral surface is a smooth surface without any edges. In prism, the lateral surfaces are flat surfaces. That is the only difference. So draw the development of lateral surface of a lower portion of a cylinder of diameter 50 mm and axis 70 mm. When sectioned by a plane cutting at 40 degrees to the HP. When sectioned by a plane inclined at 40 degrees to the HP and perpendicular to the VP, bisecting the axis. So here the things we have to remember is shape of the object, cylinder with diameter 50 mm and axis 70 mm long. It is cut by a section plane at 40 degrees inclined to HP and perpendicular to VP, bisecting the axis. So draw the cylinder with the initial view position, base on HP, top view as the true shape, front view. Already completed the projections of development of cylinder without cutting plane, but now it is development with a cutting plane. Draw the cylinder and its front view and top view. So the points be A, B, C, D, E, F, G, H are points on the base, bottom base, represented as hidden points. P, Q, R, S, T, U, V, W are the points on the top base. Complete the cylinder and divide it into 8 equal parts. Now, the cutting plane is given as it is bisecting the axis and inclined at 40 degrees to the horizontal plane. As the cutting plane is perpendicular to vertical plane, it is represented as a line in front view. It is represented as a line in front view. So, a 40 degrees inclined line in front view, bisecting the axis. Identify the midpoint of the axis. Total length 70 mm. So, midpoint is at 35 mm, passing through this. Draw the section plane. Now, the section plane is cutting the edges. Not the edges, these are the generators. The section plane is cutting the generators. A dash, P dash at 1 dash, BQ at 2 dash, CR at 3 dash, DS at 4 dash, ET at 5 dash, FU at 6 dash, GV at 7 dash, HW at 8 dash. So same, we're getting the 8 points. Now, drawing the developed surface. So first draw the rectangle, length equal to the circumference of the circle. Length equal to the circumference of the circle, pi d, 50 mm, pi into 50 mm. It is around 157, I think. So around 157 length and height equal to the axis side. Draw the development of the complete cylinder first. And draw these generators. As we divided the total circle into 8 parts, draw the generators, 8 generators. Now, project the point. Point 1 dash is on the edge AP. So, project this line 1 up to the edge AP. 2 dash is on QB. So, on 2, represent point 2 on QB. 3 is on CR. Represent point 3 on CR. Similarly, the other points. Mark all the points continuously. So you'll get this point 1 2 times as it is on the starting edge AP. Now join all these with a smooth curve. Previous class, as it is a prism, all the lateral surfaces are flat surfaces, flat rectangular surfaces. So we have joined them with a straight edges. But now for cylinder, as it is a continuous smooth surface, we should join these points 1 to 8 with a smooth freehand curve. The smooth freehand curve. So this is about projections of prisms and cylinder. That is by using parallel line method. By using parallel line. Any of you having doubts in this parallel line method? Any of you unmute your audio and respond. Parallel methods ఇంకేమైనా డౌట్స్ ఉన్నాయా? So now, no need of problem 8. One more problem on cylinder. Almost. Just only thing is, cutting plane is inclined at 55 degrees to meet the axis at the top face. Only thing is the position of the cutting plane is varying. So no need to do this problem 8. Now let us go for the problems by using so is it audible?
Yes, sir.
Okay. Our problem in college network problem. So headset is disconnecting. Now let us go to the radial line method. That is development of pyramids. Development of pyramids. The only thing is there we are going to draw the lines as the radial lines. Now I'm presenting the screen again. Can you see the screen? Is it clear? So now to the next problem. Draw the development of lateral surfaces of a square pyramid. Side of base 25 mm and height 50 mm, resting with its base on HP and an edge of base parallel to vertical plane. And an edge of base parallel to vertical plane. So here we should draw the initial square. So I'll explain it better on a board. First two problems, I will explain it on board. See the problem in chat box. So development of lateral surfaces of a square pyramid resting with one of its base on HP and an edge of the base parallel to VP. Edge of the base parallel to VP. Wait for a while. Draw XY line and a square pyramid. It is resting with an edge of the base parallel to VP. So name the corners as A, B, C, and D. Name the corners as A, B, C, D, and as it is a pyramid, represent the slant edges which are joining from the base corner to the apex. O. Project all the points to front view. Project all the points to front view. So as the base is resting on horizontal plane, A dash, B dash, C, these are the points C dash and D dash. First draw the axis line. Join all the base corners to the apex. O dash. Now we have to identify the true slant length. Here one more task is we have to identify the true slant length. So rotate any one corner. Suppose rotate AO up to with OS center, OA radius. Draw an arc up to a horizontal line from O. Name this point as A1. Name this point as A1. Project this A1 point up to XY line. Project this A1 point up to XY line. If you join O dash A1, we join O dash A1 dash, this is the true slant length. The true slant length of the pyramid. Now, with radius equal to O dash A1 dash means the length of the true slant length. At any point, mark point O, O as center, radius equal to O dash A1 dash, true slant length radius, draw an arc. Draw an arc. Join O to the starting point of the arc. Name this point as A. Name that point as A. Now, take radius equal to the side length of the square. That is 25 mm given in the problem. So with side length 25 mm, A as center, draw an arc. Point B, B as center, draw arc. We get C, C as center, draw arc. D, D as center, again arc. We get point A. Join OB, OC, OD, and OA. At the same time, join AB, BC, CD, DA with the straight edges. With the straight edges. So remember, AO is equal to the true slant length of the pyramid. So you should be careful. AO is the true slant length of the pyramid. Now is it clear? Radial line method. So it is drawn by first drawing the arc and then drawing the radial lines from the center of the arc. So note on the next one. Development of a cone. Draw the development of a cone without any cutting. So first let us describe how to draw the development of a cone and a pyramid without cutting, and then we will go for the problems with cutting plane. So the next problem is draw the development of lateral surface of a cone. So when it is given clearly lateral surface, so most of the cases in examination also, as per syllabus, will getting only development of lateral surface. No need to draw the base. So if it is given as draw the complete development, then only you have to draw the base. Means just adding one more circle or one more square or shape base of the shape. Now, development of lateral surface of the cone with base diameter 40 mm and altitude 55 mm. And here, the position of the solid is not given. So, as the position of the solid is not given, so we are assuming it as the simple position, that is with base on HP and axis perpendicular to HP. So, true shape in top view. Let us divide it into 4 parts sufficient. As it is without any cutting plane, simply divide it into 4 parts. Let the points be A, B, C, D. Now project the base points up to XY line. Project the base points up to XY line. Now these are the points A dash, B dash, C dash and D dash. Draw the axis line. O dash. Join all the base points to the axis. So this is the projection of a cone when it is in simple position. The projection of a cone when it is in simple position. Now, for drawing the arc, how to draw the arc? What is the length of the arc we must maintain? What is the length of the arc we must maintain? Suppose if you observe in this problem, what is the radius? Radius is, diameter is 48 mm. Diameter is 48 mm. So, radius equal to 24 mm. Measure the distance O dash to A dash, means the generator length. Measure the distance O dash to A dash. That is, mark this length equal to R. So for this problem, we'll get it around 60 mm. We'll get this value around 60 mm. Now calculate a value. Theta equal to 360 into small r by capital R. 360 into 24 by 60. What is this value? 24 into 6. Look at this value. 144 degrees. Look at this value, 144 degrees. Now, on right hand side of this projection, at any random point, mark point O, and with OS center, radius equal to OA, slant length of the cone, generator length. Draw an arc. Join the starting point of the arc. Mark this as OA. Now with OA, measure 144 degrees angle. Measure 144 degrees angle. Draw one more line. Now this total angle, we should draw arc for an angle of 144 degrees. Now, as we divided this cone into 4 equal parts, the base into 4 equal parts, divide this total 144 degrees into 4 equal parts. One thing is by angular bisection method, but here it is a regular angle 44 degrees. Draw lines at every 36 degrees. Either by angular bisection. We did the process for epicycloid, hypocycloids, and involute curves. Sorry, epicycloid and hypocycloid line by dividing the arc into equal number of divisions, 8 and 12. The same process, following the same process, divide this into 4 parts. Name these points as B, C, D, and A. Here, each angle will get it 36 degrees. Total angle is 144 degrees. So in problem, you have to show this angle. No need to show the calculation part, but you must represent the angle value. And complete the dimensions. What is the dimension? Diameter 48 mm. So 5, 48, and altitude 55. So this is a way of drawing development of a cone without any cutting plane. Now, the next problem with cutting planes. A pyramid and a cone with cutting planes. Now the next problem. A pyramid with a cutting plane. Hit the problem. A square pyramid of base 25 mm and altitude 50 mm rests on its base on HP with two of the base parallel to VP. It is cut by section plane bisecting the axis inclined at 30 degrees to the base. Draw the development of lateral surface of lower part of the cut pyramid. So first draw the pyramid with a given position. XY line. It is resting with its base on HP with two of its base edges parallel to VP. So, a square with two of its sides parallel to vertical plane. Let the corners be A, B, C, and D. Draw the projections up to xy line. A dash, B dash, C dash, D dash. O dash, join all the base corners to the apex. Now, it is cut by a section plane, bisecting the axis and inclined at 30 degrees to the base. So, identify the midpoint of the axis. From the midpoint of the axis, draw an inclined line at 30 degrees inclination. From the midpoint of the axis, draw a line at 30 degrees inclination. Now, this cutting plane is passing through the slant edges AO, BO, CO, DO. There this will be point 1 dash, 2 dash, 3 dash and 4 dash. 1 dash on the edge AO, 2 dash on point BO, 3 dash on CO, 4 dash on DO. Project these points up to top view. One, 2, 3, 4. Join them with the straight line and fill it with the hatching. So this is the shape of the projection of a pyramid when it is cut by a section plane inclined at 30 degrees to HP and bisecting the axis. Now, drawing the development of this lower portion of the pyramid. Development of the lower portion. Remember, only highlight the base. Leave the upper part with 2H pencil. Now, measure the true slant length. So, as AO, BO, CO, DO, these are the edges inclined to both xy line in both front view and top view. So, రెండిట్లోనూ inclined అన్నప్పుడు at least if it is parallel to one reference plane, we can take the direct length. But here all the four slant edges are inclined in both the views, front view and top view. So, rotate any one line. Rotate AO. OA center, OA radius. Draw an arc up to horizontal line from O. Point A1. Project this point up to XY line. Point A1 dash. Now join O dash A1 dash. Now O dash A1 dash is the true slant length. O dash A1 dash is the true slant length. Now, with radius equal to O dash A1 dash, with center O, draw an arc. Join the starting point of the arc. Mark point A. Now, AB distance, side of the base, 25 mm. AR center, 25 mm radius. B. BR center, 25 mm radius. C. CR center. D. DR center. A. Join. And also draw the straight lines indicating the base. Now, marking the points 1, 2, 3 and 4. So here there is a small variation compared to the previous one. That is, as 1, 2, 3, 4 are on the slant edges, but what we are seeing is not the true slant length. So what we have to do is project this point onto true slant length. Means project point 1 dash, 2 dash, 3 dash, 4 dash onto the true slant length, O dash A1 dash line. O dash A1 dash line varaku draw a horizontal line and name these points as 1 1 dash, 2 1 dash, 3 1 dash, 4 1 dash. So why? Because we must get the distance on true slant length. So now with compass, measure the distance between O dash to 1 1 dash on true slant length. O dash to 1 1 dash. 1 dash is on, 1 is on AO. So O as center, draw an arc. Now measure the distance O dash to 2 1 dash. O as center. Two. Now measure the distance from O to 3. O to 3 and O to 4 are same. 3 1 and 4 1. So draw the arcs. Join them with the straight edges. So this is the development of a pyramid when it is cut by a section plane. This is how it looks. Just a point marking is varying, but the process is you have to project point 1 2 3 4 onto true slant length, and while marking these points you have to take the distance O dash to the projected point on the true slant length. So OA is the true slant length. Is it clear? Again, doubts on the NA.
No, sir.
Now, see this problem. A square pyramid, base 35 mm side and axis 70 mm long, rests on its base on HP such that two adjacent edges of the base are equally inclined to the VP. It is sectioned by a plane perpendicular to VP inclined at 30 degrees to HP, passing through the midpoint of the axis. Here the cutting plane is almost the same as the previous problem, passing through the midpoint of the axis and inclined at 30 degrees to HP. But the variation is all the base edges are equally inclined to the VP. All the base edges are equally inclined to the VP. So in top view, we have to draw a square with all the base edges equally inclined to the VP and complete its projections. So better I will show it on the board. So first, as it is given, all the base edges are equally inclined to vertical plane. So in top view, we have to draw the pyramid, a square with all the base edges equally inclined to XY line. If you go through the problems, projections of solids and projections, sections of solids, you can find the same problem. So let this be A, B, C, D. Drawing its respect to front view. A dash, B dash, C dash, D dash, join all the base corners to the apex. AO, BO, CO, DO. Now, it is cut by section plane, bisecting the axis inclined at 30 degrees to the base. So, identify the midpoint of the base, draw the cutting plane, inclined at 30 degrees to the base. Now, this cutting plane is intersecting slant edge AO at 1 dash, BO at 2 dash, CO at 3 dash, and DO at 4 dash. Project these points onto top view. 1 dash is on AOH. Point 1. 3 dash is on COH. 2 and 4, if you draw the projection, you'll get it a coinciding line. So what you have to do is draw a parallel line to XY line up to AO slant edge. Mark this point as 2-1 dash and 4-1 dash. Now project this point. With O as center, I'm taking this as the distance. Draw the arcs on both the sides. These are the points 2 and 4. Join 1, 2, 2, 3, 3, 4, and 4, 1. Complete it with hatching. This is the we have completed up to projection of solid and section of the solid, a pyramid. Now drawing its development. So for drawing the development, first we have to identify the true slant length. If you observe in this problem, AO, CO are parallel in top view. So it is parallel to XY line at least in one view. So in other view, these two lines directly imply the true slant lengths. So here A dash O dash and O dash C dash are the true slant lengths. Measure this length with O as center. Draw an arc. With O as center, draw an arc with radius equal to A dash O dash. Now measure the distance A to B. Side length 25 mm. A as center, draw an arc. B, C, D, and again A. Join OA, OD, OC, and OB. This is development of pyramid without cutting plane. Development of the pyramid without cutting plane. Now with cutting plane, measure the distance from O to 1 dash. O to O dash to 1 dash. As 1 dash is on OH with O as center. Mark the point 1. Now measure the distance on true slant length O to 2. On true slant length, not this distance, O to 2 on the slant length. So 2 and 4 are at the same height. Now coming, measure the distance from O to 3. So again, this is also on the true slant line. Only variation is for point 2 and 4. Project this point 2 and 4 up to true slant line. And you have to take the distance on the true slant line. Point 3. Join all this with the straight edges. So this is a way of drawing. So why I have shown the two problems? Both are of square pyramids. The only variation is in previous problem, all the base sides are parallel and here all the base sides are equally inclined. What is the variation is? In previous problem, there we have to follow the process and measure the true slant length calculation, and here no need to rotate the line or no need to do a process for calculation of true slant length. Directly we are getting from top view the true slant length value. Now I am forwarding the PPT as all the problems are of same model. To complete all the problems what I am forwarding or what are there in the PPT. As all of them are same models, I am not explaining each and every problem. But solution and problem, everything is there in the PPT. Can you do it or not? Chegalra? So then 10 problems chepna, 20 problems chepna, as the procedure is same. It is unnecessary time of waste. So I'll move on to one more problem. Observe this problem. A cone of base diameter 60 mm and height 70 mm is resting on its base on HP. It is cutting by a plane perpendicular to VP, inclined at 30 degrees to HP. The plane bisects the axis of the cone. Draw the development of its lateral surface. Draw the development of its lateral surface. So, first draw the cone, top view and its respective front view. Divide it into 8 equal parts. So, draw all the generators. And next, the cutting plane. Draw the cutting plane. Inclined at 30 degrees to the HP and bisecting the axis of the cone. And bisecting the axis of the cone. So draw the cutting plane. Now mark the points on this cutting plane. 1, 2, 3, 4, 5, 6, 7, 8. Take it in order. 1 is on the generator AO. 2 is on the generator BO. 3 on generator CO. 4 is on the generator DO. Similarly 5 on EO. 6 on FO and so on. Now for drawing the developed surface, so here actually I forgot one thing, to draw the sectioned top view. Project all these points onto the top view and draw the section area on top view. Now calculate the angle. Theta equal to small r, radius of the base 30 mm and slant length. Measure this distance between O dash to A dash. measure the distance from O dash to A dash. That is, we're getting 76 mm. So total theta equal to 142. So 142 by 8 equal to 17.75. So directly 17.75 mark cheyadam difficult. So what you have to do is, with OS center and radius equal to 76 slant length, draw this arc for total 142 degrees. And now, by using the angular bisection method, divide this total angle into 8 equal parts. The best way is by angular bisection. By using other methods, you don't get the accurate value. Protractor use చేస్తే ఎందుకంటే here the angle value is 17.75. Exact mark చేయడం difficult. So divide it using angular bisection method. చేసి divide this total into 8 parts and mark all the points A, B, C, D, E, F, G, H and again A. So now distance తీసుకునేటప్పుడు project all the points onto the true slant length. Already one is on the true slant length. So project the remaining points. No need of 5. Why? Because again 5 is also on true slant length. Actually it is shown here, but no need of projecting 0.5. The remaining points 2, 8, 3, 7 and 4, 6. Project it onto the outermost generator OA and name mark these points as 2 double dash, 8 double dash, 3 double dash, 7 double dash, 4 double dash and 6 double dash. So now measure the distance along the true slant length. O1 distance. O as center, draw an arc. Next, O2, it is on BO. So on BO, O as center, mark 0.2. 3 is on CO. O as center, measure distance on true slant length. Mark 3. Similarly, 4 is on DO. So measure the distance O dash to 4 double dash. So similarly, mark all the points and join them with the straight line. Smooth freehand curve. Sorry, not the straight line. Join all of them with the smooth freehand curve and complete the development. So with this, we completed the development of surfaces. Actual, మీరు problem to problem variation కాకుండా understand them as a single concept. If you understand them as a single concept, you will understand them easily. Now with this, I am concluding this. ఇంకేమైనా డౌట్స్ ఉన్నాయా ఇన్నిట్లో?